In this video, I'm going to talk about two common mistakes I see students making on this project. The first one deals with the two-tailed test. You get your test statistic and you're trying to find the p-value for it. So you might you would type in t.distribution.2t for the two-tailed test. You're going to get the p-value. And the first argument we need is what our test statistic is. Now, if you have something like, let's say your test statistic was negative 0.2. All right, negative 0.2. And then the degrees of freedom, 99. When we type that in, we're getting this error. And this is a cause of confusion and errors on this project. The error is coming up because this has to be a positive number. Your test statistic needs to be positive that's just the way Excel has it set up for this two-tailed formula. Now, the t-distribution is symmetric. And so all we need to do is use the positive version of whatever our test statistic is. So let's say you had negative 0.2. What we're trying to find out is the probability of being that far away from the center here. This is the center of our distribution. That far away into the tails on either side. So from there or from positive 0.2, we want our formula to tell us what's the probability of being in either one of those shaded regions, at least 0.2 away from the center. And so just don't use the negative, use the positive version. And that way the formula works in Excel and you actually get the number back, the probability of being within the shaded region, like I have in this example. Now, if you started off with a test statistic that was positive, then just use what you got. If you came up with a negative one, just drop the negative and type in the numbers as a positive, and that formula will work. Now, the other error I see is when people have a very, very large test statistic. So let me make something up here like 7.5. A large test statistic, you're going to get a really small p-value back because a large test statistic would mean we're way out here in the tail, really, really far away. So the probability of being that far away, symmetrically on both sides, two-tailed, is really, really small. Just this tiny portion of the distribution is that far away from the middle. So a large test statistic, you're going to get a very small p-value. But Excel returns the p-value in scientific notation. Remember, a p-value is a probability, so it has to be between 0 and 1. Probabilities are between 0 and 1. This number, 2.78, is incorrect if you think that's your p-value. Excel is saying in scientific notation, this E-11 means the decimal needs to move 11 spots to the left. Multiply by 10 to the negative 11th power. That's what the scientific notation is saying. So this p-value for our large test statistic gives a very small p-value. Move this decimal 11 spots left. Our actual p-value is that right there. A very, very small number between 0 and 1. So if you see E negative anything, you have a very small p-value, and I just wanted you to be aware that Excel is showing that there in scientific notation. And look, it converted it back to that when I typed in a very small number. But that is how many decimal spots to move the decimal point in order to get your actual value.